Hey guys, how's everything going? This is JSer, who is not good at algorithm. I'm making these videos to prepare my future interview in June from Facebook. So I've attended the LeetCode weekly contest just right now, and had a hard time solving the first problem, which is his destination. I took 30 minutes to come up with a very naive solution, and it is TLE. And I suddenly realized I could improvement into n square, and then finally improve it into a linear time. So that's very cool. I think I'll explain how I did it. So we're given the problem this like this. We're given a bunch of array. Each array is a path from to. So return the last city, destination city. We're guaranteed that the graph comes from a line without any loop. So the input is always valid, and it will generate a line like AZ. The last one is Z. So how can I solve this problem? Well, the naive solution would be to just merge the two paths together, right? Like BC and DB. Okay, we found B, so we merge it. And merge it so these two array will collapse into one. And finally, there will be only one path. There will be a one element in this array, and we can get the last element. So that's the first solution. Merge the paths. So how can we merge it? We could just traverse through all the paths, and like we're getting BC, we just look through all the rest paths and find if the head matches or the tail matches. If it does, we merge the rest. Of course, we need to pop the first one out, right? Okay, so while pass.length is bigger than 0, now for the rest of the paths, if they could be merged. If head 0 equals to paths I 1, if something like this, we could just update the B to C, right? So paths I1 equals head 1. When we merged, we could just break, or we can continue doing it, but the head hasn't changed yet, so I'll break. If head 1 equals paths I 0, also we update. What do we update? Like the C for here, we update the head to B, right? So head 0, and then we break. So we can now, because the input is always valid, this will be merged at some point. And so at last, there will be only one path. Only one path, so we just return path 0, 1. Let's run the code. Oh. Some syntax error. Break. This is a for loop. This is while loop. Undefined. 1, sorry. Cool. Let's submit. Wow, it's fast. It's faster than 100%. Really? I couldn't believe it because maybe the okay, the chart isn't generated yet. So let's analyze the time complexity here. Well, this is a for loop here. This is while loop here. So here's just an n, and then this is n. Obviously, the time would be square, and the space would be constant. We don't use extra space, right? Okay, now let's try to improve it. So this is what I came up with at the last minute. It turns out that maybe we don't need to merge the array. We could just let's say okay, we have a C to B and we have D to B. So we say, hey, we just pick any array like the path like the first one. I say, hey, is there a path from C? And say, okay, we find it here. So okay, we'll go to okay. Is there a path from A? No. So A is the last one, right? We don't even need to merge this DB, right? If we get BC, and then we go to CA directly. So that reminds us with the second solution. We just collect the result directly. So what does it mean? Well, for direct access, we need to map, right? This array format isn't what we want. So we use a map equals new map. Actually, just initialize with paths. Cool. Now we just pick the first one, right? But for map, how we could pick for first one? Well, we could just do a trick. Let any path of map break, so we can get the first one. Now we get one. So what do we do? Okay, we say we start with any path 1. So while what? While there is a path. While there is a path starting from this C, right? If there is, we will start set it to map get start, right? And then this will let's start. It will end at last destination. So finally, we return start. That easy. Let's review it once more. This map, any map. Okay, we break. Sure, they get the start is the C. Does map has C? It has, so we get start. Yeah. That easy. So the time complexity for this one is when we get generating a new map, it's obviously it's linear time, and for this one, it's linear time, and it's much better because for worst case it's linear time. So it's internet plus worst linear time. So it's linear time, but space we use a map to keep track of the paths, right? So we use extra linear space. So cool. That's all for this problem. Hope it helps. I think the last solution is very cool, but it might not be that easy to come up with this solution at a shorter period of time. Anyway, hope it helps. See you next time. Bye bye.